I'm going to explain about BiCMOS inverter. We know that the inverter function, when you are giving 0, it gives the 1 output, and when you are giving 1 input, it gives the 0 output. So this is only the symbol. If you want to design the internal circuit, it requires the transistors. So you have seen that already, that is NMOS inverter and CMOS inverter. In that, only 2 transistors are required. So, but here in this BiCMOS inverter, so that is NMOS transistor is required, NMOS transistor, that is PMOS transistor is required, and these are the bipolar transistors, that is BJT, emitter, base, collector, and here you can see this emitter, base, collector. So both the transistors we are using, that's the reason it is BiCMOS, bipolar technology one side and MOS technology one side. So CMOS technology. So that is, these are MOS technology, CMOS technology, NMOS and CMOS, PMOS combination. So that is named as CMOS technology, and this bipolar technology by BJT transistors we are using. So hence it is named as BiCMOS inverter. The final aim is, while giving the input is 1, we should get 0 output. While giving, if the input is 0, we should get 1 output. That is a function for the inverter. I will explain here. So here you can see this, I am giving 1 here, 1 input, and here it is a PMOS transistor, source gate drain, source gate drain, and this is NMOS transistor, NMOS transistor, source gate drain. So now we can see this, when you are giving 1, so here there is a sufficient VGS input, and here there is no sufficient VGS to ghost the transistor T1 should be on condition, hence it will goes to off. So if it is off, there is no sufficient VB, so across this, that is emitter, base, collector. So if it is off condition, there is no flow here, so hence it is also goes to off condition. So here if both are off, so here it is acted as open circuit, so there is no flow from here to here, no flow, so hence the output is 0. So in the second case, I'll give you, even though if it is on condition, VGS is sufficient, here it will goes to on and it will goes to, there is a sufficient VB, it will goes to on, in this case, same case. But there is no VDD flow from Q1 to Q2. So that's the reason. So Q1 to output side, so hence the output is 0. I will explain about the second case. You can see this second case. What will happen? When you are giving 0 input, so now what is the output you should know. So this 0, here 0 to, just assume like this, 0 to negative, or else here there is a sufficient VGS to ghost the on condition for when you are giving 0 input. Just assume here 0 means, assume that it is a negative to positive, so it is reverse bias, it will goes to off condition, or else originally there is no sufficient VGS here. When you are giving 0, there is no sufficient VGS, automatically it will goes to off condition. If it is off, there is no flow from, that is transistor T2 to Q2, so hence it is also goes to off condition. Coming to here, when you are giving 0, so 0, there is a sufficient VGS, or else 0 means negative to negative forward bias on condition. So if it is on, the current will flow from source gate drain to base VB. So there is a sufficient VB, so it will goes to on condition. So now we can see this is off and this is off. So then the VDD is flowing through this direction. Hence the output is high. hence the output is high. So like this, it will generate either 0 or 1. While giving 0, it gives 1. While giving 1 input, it gives the output is 0. This is about BiCMOS inverter. Thank you.